Hey calculus folks, here's a quick video on just to get you started so you make sure you know what's going on with this thing here. Oof, it's a little too big. Let's go. Oh, nice. Okay, so it says fill the first initial of each student in this math teacher's seating chart using only the clues below. So you'll see there's no repeats of first initials, so you can just throw those in there. These are all math masters. But one thing I want you to notice about the seating chart is there's your y-axis and there's your x-axis. So this would be the point 0, 0. So let's say Riemann came out and your answer ended up being 0, 0. Well, you would put an R here for Riemann. Or let's say Newton was at 2, 3 when you did your calculation. So I go right to 1, 2. This is 0, 1, 2. 1, 2, 3. Here's the point 2, 3. Does that make sense? Hopefully. So yeah, it says your x's go from -2 to +2. So this is -2, -1, or 0, 1, 2. And then your y's go from -1 up to 3. So just realize if the line goes through, here's -1, 0, 1, 2, 3. When you're doing that. And you can write on this with the Cami software, or you can print it out. So let's just start off with Wallace is seated at the minimum point of this function. This is an easy one. So if we did this together, there's a couple ways you can find it. If you remember from Algebra 2, you can find a minimum by doing -b over 2a and plugging it in. There's other ways to do minimums, like take the derivative. So the derivative of this would be, let me see if I can get Cami working here. Let's see. I'm hitting this Cami thing here. Yeah, that's me. Okay, it's open for my computer. Oh, cancel. Google Drive. Alright. Well, you might have to do this too. Maybe you have to make a copy of it. There it is. Class, take your seats. Come on. Yeah, there it is. So now I can draw on it. So let's say I wanted to actually do the derivative. This is much better if you have a touch screen. Okay, so f prime of x equals, so here's a way to find a max or min. Take the derivative, 2x, wow, this doesn't look good, minus 2, and set that equal to 0, right? So 0 equals, I think you could also type in here, 2x minus 2, and then you take the 2 to the other side, divide by 2, and you get x equals 1. So you know from your work with critical numbers that where the derivative equals 0 is either a max or a min. They already told us there was a min. So it's not like I'm guessing. And I'm going to plug in the 1 to the original equation. So f of 1, okay, f of 1 is 1 squared minus 2 plus 4. So 1 minus 2 is -1 plus 4 is 3. So basically that tells me it's the point 1, comma 3. You also could have found this by using your graphing calculator and graphing that equation and seeing where the min is. So what do I know? I know Wallace is 1, 3. Sometimes you'll have a couple answers, and you won't know which one it is till you see later on. Like if this guy has 2 different points possible, and someone else has just one of those points, you'll know which one to eliminate. So let's see, 1, 3. So I'll go right 1, up 3. Here's a W. So Wallace sits there. I'm pretty confident in that. Check. Okay, so we're good on that. And then you'll go through and do each one of these. Inflection points. Sits on the curve, this curve nearest to bool. So you'd actually have to know where bool is. And kind of graph this. Here it's on a maximum point. So critical numbers, you'll have to find a couple of them. Anyway, so it's basically a cool little puzzle. It's good review of your skills of finding critical numbers and inflection points and mins and maxes and tangent lines and all that sort of stuff. So anyway, give that a try, and hopefully this shows you what we're looking for in the end. I'm going to put not a Google Doc, I'm going to put an assignment in Classroom for you to take a picture of your stuff when it's all done. And yeah, hopefully that helps. Talk to you later, people. Hope you're doing well. Miss you guys.